the club. Okay, now we're live. All right. Well, welcome to day 2 of the Spring 2024 meeting. Today is going to start out with a few more talks on HTM efforts that recently were funded. We'll talk about the Science Platforms Coordination effort that's ongoing, and Sean's going to present on that, as well as show us a demo of the current PyHC environment. And then we'll be discussing a Heliophysics software search interface. I've invited an outside presenter to come and speak to us about something that they've done for exoplanet research. And then we'll move on from there. So, Alexander, take it away.
Okay, so let me share it first. All right. So let me know when you see it, and let me know when you see the to talk about PySpeedas.
It is up.
It's up. All right, thank you. So I'll be presenting 2 talks today about the HTM project. The first one, and I think I'll do just them consecutively, and then we can discuss the questions. So the first one is about the new magnetometer data access from seismological network for the space physics research, and it's available via PySpeedas. So this project is almost done, and I just like to share what we accomplished. So you might have seen this map yesterday, and actually on the previous PyHC meeting when I presented for the first time, but this is the map of the US array of the seismological stations, and some of them has magnetotellurics measurements, and why not to have them, because we can actually access them for free. The only problem is a bit complicated, and what we're trying to do, we're trying to provide an easy access for this data. There is an MTH5 tool that was developed with collaboration with USGS that provides this interface to this data, which is in FDSN and IRIS network. And our piece is to get this interface, connect them together, calibrate, do all this fun business, and provide very easy access for users to be to make them happy for the space physics research. And those magnetometers are very important for the space weather research, as mentioned in the Ingebretson paper. So this is the motivation why we decided to do it in the first place. So MTH5 structure, it's actually quite complex, and it is required for seismological people, but for us, we just need to get the data and give the dates, give the name of the station, and just use it. But for them, they need to they have experiments, experiments built into survey built into station, and station consists of multiple runs. So they work actually with the, for them, it's very important to have a continuous run without, when the detector was turned on, and until it turns off, it's just a single data set. And this code is what you give access to the a single run. But this is what we want to do to not just load the data, but to load and to plot the data for the end user. So again, it's the access, and we achieved that, and I will show the example of it. So I would like to share the comparison with published results. So what you can see here is the figure from Heinz et al. 2021. Here, the blue line is the magnetic measurements from FRD station, and FRD station is not part of what we're doing. It's a golden standard, actually. It's the EMAC network station, but it's used in space weather as I said, as a golden standard. What we can do, IRIS actually have this very nice map, and we can put coordinates of the station and put some circle around it and select the dates and see if we have any active station at this time. And in fact, we do. There are several stations that were available and provide magnetic measurements. And with our implementation, this load FDSN, essentially, literally the one function that's you need to use to get to the data, you can easily access. The previous line is something that was already built in SPEEDAS to get the data from FRD, and after just simple median subtraction, we can easily plot these 3 components. And as you can see, they all look very similar. So FRD is the same as from the published results. So that proves that what we did works well. And now we can, like, the scientists can actually get into and do some research. This example shows also what else can we do with this tool and why it's important. So those are all stations that I showed on the previous slide. And you can immediately start to see that there is some data that has some spikes, unusual spikes. And this one we discovered, this magnetometer, if you can see, it's actually inverted. So likely the folks installed this REQ48 upside down and didn't even know about this. But with tool like this, you can easily inspect the data and find like mistakes like that. We're planning to contact to them. So previously, when I showed this at AGU, this station was not even like showing any data, and because we presented at AGU, they fixed it, and now the data is available. So it's already brings some, our activity already brings some positive feedback. So you can access the Jupyter Notebook by this link that generates this plot, and I'll show you in a second how it works in Google Colab. The Jupyter Notebooks were moved from SPIDAS project to SPIDAS examples to be in compliance with PyHC, and so far it lives in its own branch, and I'll explain in a second why. So that is an example how you can, anyone right now just can go and access, if you have a Google account, you can go and access the Jupyter Notebook via Google Colab and run it. And I literally executed yesterday to make sure it works, and it does. Like run it yourself. The only thing you need to do, you need to install the dependency, not from Python packages, but from Git for now. So in March, there is a schedule for the release that for this MTH5 tool and MT metadata tool in Python packages, the new version that supports all the changes that we had to do to make this happen. And as soon as it will be done, we also merge our tool with SPIDAS main branch, and essentially that pretty much will be the completion of the product. But we're very excited that we're almost there at the end of the journey. And final, a very new addition to this development, we include this data availability functionality when you can request the specific time range, select network or not, select stations or do not select the station. And what it gives you a list of all available networks and stations and the period of their availability within this range of the time that's you selected. And that could be useful if you want to see some other if you don't want to use this map that I showed earlier, there is a built-in tool for that. So that is all I have in regards to first project. If there is any one quick question, maybe I can answer it right now while I'm changing the slides. Please free to pop up in, like, unmute yourself, I guess.
I'll put the placeholder question here. We can talk about it later, but what would it take to get that data accessible with Happy? It's time series, it's got availability. That'd be awesome. We've talked about this before, but anyway, I'll queue that one up.
Okay, yeah, I think I know the answer. I'm trying to find the Zoom when I share another presentation. I think I should have just combined them. Think of it. All right. Thanks for the question. Yes, about Happy, I will probably let you know. So the second project is just started. It's about radiation belts analysis and modeling library in Python, or RBAM-lib. So this motivation from this project came from the library that's was already existed. The library, similar library, was available and built by UCLA in collaboration with GFZ in MATLAB, not in Python. And here you can see the screenshot of what we've done. But essentially, it was just a kind of like mishmash of different people trying to work together because we had the need for something like that, for some library. And researchers that not even in the field anymore, they start to make this library, and it was never meant to be for the available for the public. It was kind of internal library that's grow over time, and it's not very well tested. It has this is one of the good example of the documentation, but generally it doesn't have much of documentation. And despite all of that, it was extremely useful for many studies. And it's almost a crime that there is no such a library exist in Python. And kind of checked because I needed this for my research. There are some functionalities, but nothing that we can actually use for the radiation belts research. Well, now there will be such a library. Yay. And when I was thinking about how to organize this code, I also contacted Sean, and I discovered that most of the packages, PyHC packages, they live within their own organization, but there is no organization for radiation belts codes, essentially. And I did a search in the GitHub, and there are surprisingly not many projects and definitely no organizations that support radiation belts research. So I ended up creating one. So this is an organization that's called Radiation Belts that hopefully will be home not just for the project that I'll be talking, but for other projects as well. And as you can see, even GitHub recommends minimum 2 people within the organization for each role. And now it's only me. So I invite everyone who wants to participate. Please let me know. I'll be happy to talk to you about this. So now to the library. Again, there is not that much progress. Our project just started, but I already created the GitHub page within the Radiation Belts organization. And again, the library that I'm working on is supposed to be a lightweight. It essentially will have minimal dependency. It's only NumPy for now. And I want to keep it as simple as possible. It will be open source, obviously. We'll be welcoming for the contribution, and I will explain why contribution is important. So the content of the library, how I vision, it's not just a direct port from the MATLAB library, it's extension, and I want to build something on top of it. It will consist in essentially 3 parts. It could be many modules, but 3 parts. System properties, it's a set essentially of basic equation that everyone can use without rewriting them and making mistakes. It's the modeling support, and by that I mean encapsulation of routine tasks that we have quite a lot. And again, having those routine tasks may help to students and postdocs to start modeling. And I've seen how this happened with this MATLAB tools that we have. And finally, and this is the most exciting part, I think, it's a collection of empirical models. And here, where can I see the most contribution should be happening? So I would like to include a set of published equations. So if there is an empirical model published in a paper and there is a literal formula written, we usually end up taking this formula and writing our own equation in our own code and using it. With this library, it's going to be a home for this kind of equation. So again, there is going to be less error, less chance for making error. You just can take it and use it right away, like empirical lifetimes, plasma pose location, etc., etc., etc. As for the documentation, I gotta say this project was kind of inspired by the previous PyHC meeting by Plasma PyTalk. I have to give it a shout out. When I saw it, how it's all organized, I thought we can do the same thing for radiation belts. Why we don't have it? And when I start researching, again, discovered that there is none, and now there is a whole project to that. And the idea behind the documentation that's every single function will have a corresponding equation. It's very easy to include. And when researchers will look through this documentation, they will see familiar equation and can use the corresponding functions right away. So documentation is already like the rudimentary, just the beginning of it, is already available on Read the Docs. Testing, for testing, I'll be using unit test, and I already wrote a bunch of tests. They obviously all passed, they're really fast, and there's not much to tell here. I'm working on making automation for those tests through GitHub Actions. It's not automated yet, but it will be. Finally, this is the most controversial topic, the architecture. The way I envision it, and again, it resembles the MATLAB architecture, then one function will be included in its own Python file. So the Python's files essentially are modules, but I will be treating them as the functions, and modules will be treated as packages will be treated as modules. It requires including the explicit import in init.py. There are pros and cons in this approach. The pros here, you will have less problem with merge conflicts, if any, because you'll be like people will be working on different files if needed. There is also, if there is any private functions that needs to be used for empirical models, they can be included on a top level in the same file, and explicit tests can be written for them. So I saw that as a benefit, and I would like to keep this structure. But if there is any strong opposition to this approach, now it's a very good time to discuss to it and change it, because the project is just started. So please let me know. And how you can let me know? Well, I invite for the contribution, and I hope you're all familiar with this interface. So the GitHub issues, please send GitHub issues for this project. You can do it already right now. And if you would like to develop, join into development, you can join the core team, which is only I am at this point, or follow the usual best practices, the fork the repository and commit to new branch and send the pull request. I include the already short description on the GitHub. So that's all I have. My email is there if you would like to contact me in the future. So thank you. I would like to take questions from here. And first, let me just answer for the happy question. So we do provide right now this access through PySpeedas, and if there is any direct access, will be in the future for PySpeedas variables through Happy. We can make this work. I don't think we have this at this point, because we don't host the servers for the MTH5. We provide just the easier access. The way how it works, MTH5 tool generate H5 file locally on your computer from all this complex structure, and we get through this file, read them, and apply calibration and extract just time series and three magnetic components and enclose them in a tplot variable. So this is how it works right now. And they do have, not quite happy, but they do have some ASCII interface for the data availability. So it could be done maybe through like a layered interface on top of what they have to get the happy working. But there should be a dedicated server for this. So I don't know if anyone wants to create such a server.
Yeah, that's a separate project to create a static set of cleaned, regularized data and then serve it somehow. But but yeah, you've done the hard step of regularization and the interpretation and all that. Well, it's interpretation, regularization, and then availability. So that, yeah, that's awesome. But yeah, that's almost like another NSF project or something, to take this data and capture it in a way that's useful for space physics people.
Yeah, we actually was thinking is the next project include also electric data, because some of them, they do have electric data measurements, and the GMAC data is available through some Themis activities. And maybe if we can include Happy on top of all the Themis GMAC magnetometers and PyHC magnetometers, not PyHC, the MTH5 magnetometers, that could be also a good project. So yeah, we'll think about this for sure. Yeah.
If you want to propose that together, or you need a happy endorsement on that proposal or whatever,
yeah. I will discuss it with there are a few other people who works with that project, but we're definitely thinking about what's the future, because again, this is pretty much ended. Thank you, John. Yeah.
There's lots of questions in the chat. I just wanted to say congratulations on this work.
Yeah.
Thank you. Yeah. Unfortunately, I don't see the chat. Let me see if I can.
It's really the most recent 2 comments. Well, actually, Ashley Smith has a question in there. So Ashley, I'm not familiar with the radiation belts community.
Okay.
Is PRBEM on your radar?
PRBM is, yes, so PRBM, the main activity is the PRBM library, and they mostly focus on the magnetic field, and they do have a Python wrapper. But again, before starting writing this project, I did check the SpacePy, PlasmaPy. I looked for the functionality of PRBM, and what we have right now, so this core functionality, empirical models, only few empirical models exist within SpacePy. My idea is to extend it to the full list, and the problem is when you install PRBM or SpacePy, they're pretty heavy packages. So like I tried it yesterday, it's already several hundred megabytes. And I want to build it with only NumPy as much as possible, and basically complement, not to not to take the bread away, but the complement, so it can be used together with SpacePy capabilities. And there is no units because I want to keep it simple, and it was based on my experience, the way how we did in radiation belts modeling. So we don't need to have a complex interchange with the units. So we just need to use it like for the setup modeling and run it. The empirical models from the SpacePy, there were plasma pulse location from Carpenter and Anderson, and radial diffusion, one parameterization of radial diffusion, I think. That's the last time I checked. And I think John, I think, can correct me if he is here on the call. There was about, oh yeah, I just installed it yesterday with pip install, and just a speed like SpacePy installation. I think it's dependencies. I think it's dependencies that takes away, like it grows into like 300 megabytes. I think the whole virtual environment.
It's a, well, I mean, if you're talking the whole virtual environment, that's gonna be quite a bit. And I mean, it's not exactly like huge. I mean, it's like it's Matplotlib and NumPy and SciPy. So this is not ridiculous, out of left field kind of stuff.
Yeah, SciPy is quite huge. Yeah, I actually want to avoid using SciPy for now as much as possible. And the reason why is because I envision this library to use in the modeling setup. And for the modeling setup, if there is a need for a containerized version, it's just it would be good if it's lightweight. So this library was used in the Space Pager project, if you are familiar with that, and they did do a lot of containerization, and they did start moving some of the codes to Python, and they also consider, can we use SpacePy for this? And they decided to write their own, and it's like I was surprised that they wanted to write their own. I don't know exactly what was the reason behind them, because I was kind of sideway contributing to this project, but it definitely shows that there is a need for something lightweight like that.
Okay, there may be more questions in the chat, but we should probably move on to Brent's presentation.
Agree. Thank you.
Thank you again. All right, Brent, take it away whenever you're ready with your two projects.
Just want to verify that everybody can see that.
Yeah.
Okay, cool. So this is going to be a quick overview of two HTMs that were selected and haven't really started yet because they were recent. And so I'm part of both of them. I'm the PI for SPLOT, and the first one listed there, Winley Mo, is the PI of. And so I'm going to quickly cover just an overview for both of those, and then take any questions that people will have. So the first one is cloud compatibility, and it's basically addressing how most PyHC packages rely on local data storage for any type of file I/O, whether it's getting spacecraft data or instrument data to and from a local system where the package is run. And so if you think about trying to move to the cloud, these file systems, as far as like what is currently there, would fail if given an S3 or a cloud-based file path. And so one motive for this would be trying to put it, run it on the cloud locally, where the storage is basically adjacent to the code. And that's actually pretty expensive, not scalable, and really not accessible to others. And so this HTM is meant for kind of switching to use S3 object storage for this compatibility. Initially, we focused on 3 PyHC packages: PySpeedS, SpacePy, and SunPy, because they have a lot of I/O calls, but then also they have methods in them that are pretty generalized or abstracted to do any type of file I/O operations, which means that if we can modify or append to those methods or the readers, the impact would be small to the packages and the developers to accept this. And so we've also chosen to do AWS due to it being primary in the market. And then also because it is an HTM, we've chosen to not do a full cloud agnostic proposal for this. And so we also want to use what's kind of reuse what's already out there. And so a lot of those packages that that we're kind of portraying with these modifications is pandas, cdflib, and astropy io.fix. They've already integrated in those packages S3 awareness and compatibility. So speaking of S3 awareness, so the 3 packages that we've kind of aimed for this work, it would allow users to, for PySpeedS, would allow users to save data to S3 locations, but also access data from the S3 locations as well. And then with SpacePy, just looking at PyCDF and trying to recognize when an S3 address is given to load data, and then also with SunPy, just to extend those handlers to recognize S3 paths. Kind of examples of these implementations would be reading a data locally and then writing it to an S3 bucket, reading a data from S3 and writing that to local storage, and then reading and writing both on S3, and then also directly streaming data, so that would reduce costs as far as egress. And then some of the benefits that we're hoping for as far as this is to access a lot of mission data that's already stored on S3. You can think of STO and also MMS. And then you can also take advantage of this, the wealth of the resources on AWS, but then also the scaling effects. And I saw there's several things in the chat, but I'm going to keep going before I take questions. So the second HTM is actually sort of a look at kind of taking a step back of how we visualize data. And so a lot of the times as scientists, we look at time series plots. An example is to the right there from PySpeedS, and hardly do we ever consider context. We do as sort of an after fact of like, okay, we see an event, where does this happen? And so with the plot on the right, there's no context given here spatially. And so the aim of this HTM is to give some of that spatial awareness. And so our thought was PySpeedos has implemented tplot, so we wanted to do something similar, but instead of time series, we want to do spatial. So we want to do splot. And so don't read a ton into this example image. This is just a prototype of like putting sort of a layout together, but then also implementing several packages already out there of data. And so you can see the in-lieu model of the plasma density here with, different structures and also spacecrafts put in their positions around the sun. And then also the corresponding plasma data from like stereo A. So that would have an inset of a time series where you can actually visualize how this would behave over time, given its position around the sun and in its orbit. And then the lower panels, just some views as far as like a solar view. And so like you can think of a spacecraft. Granted, this is not to scale, of course. And then these, you can think about its trajectory, but then also the data along the trajectory. So you could see in time just how the activity of the sun and then also the instruments up on board SOHO would behave. And then again, also with an Earth-centric view with MMS, and then also like the magnetic field along the trajectory there. And of course, these are not in scale. If it wasn't scaled, these would be probably a fraction of a pixel. And so we're working on that part to put it plainly. And so we just want to give more spatial context to our data, and then also be able to see things more in context that like when events happen. And then, yeah, and so I'll stop sharing and then try to get some of those questions.
Just a little bit of conversation happening in the chat.
Yeah, just a little bit.
Very cool visualizations, though, I gotta say.
Thanks.
It looks like they
Which
start
ones
with Nabil.
Nabil, can you explain your question? If you're online. Oh, okay. Oh, it was for the previous slide. Okay.
Oh, my bad. Misinterpreted.
Okay.
Then Rebecca started it off.
So are you meaning H5 Pi or H5 net CDF? Is that a new combining of the two? I'm aware of net CDF and then H5 Pi separately.
No, there's an H5 net CDF where they have some S3 capability pulled in.
Okay.
Found this about a year ago. I can direct you to some things I did with it at that point. But it's only good for H5s and NetCDF. There's problems with doing NetCDF 3. I don't know if there's support for CDF, but there you go.
Okay. I do know that some of the packages use CDF-lib, which is different than the NetCDF, if I'm not mistaken.
Yeah, I think you're right.
What was the question? Could you repeat the question, please? Could you repeat the question, please? I can't see it in the chat.
It's in the chat. It says, have we looked at
sorry, I didn't
H5
join.
CDF?
You can't see the chat unless you you can't see the chat unless you joined in time. So sorry, I was late. Could you just repeat the question, please?
Sure, I was just asking Brent if he had looked at H5 NetCDF, which is what X-Array uses.
For
the same problem, for accessing data on S3.
Okay, I see. Mostly our packages already use some sort of data reader. So most of them are CDF lib, which is also S3 compatible, or you can at least access data from S3. So our objectives are really just to transform those so that it is it can recognize S3 addresses and stream data from S3. So I think the HD the other data format that you're talking about, it would have to also play with some of the package that we're talking about. And most of them don't, since they already have their own S3 reader. But that would be the root of where you would fix the S3 reading, is from whatever package reads in that data file.
Right, I was just suggesting about incorporating a dependability that already has the problem solved for some file formats, but I don't think it's the same file formats that y'all were talking about. And you're called Mo1 in the name. I don't know what your name is or what association
Mo.
you have.
She is the PI for the S3 awareness.
Okay. Okay.
HTM.
Cool. Yeah, I didn't see a list of file formats that y'all are working with. I saw a mention of CDF, maybe. Maybe I heard that.
It was CDF lib.
Okay. Well, there you go. Useful or not.
I see that Jonathan.
Yeah, what other things are being listed in S3 that this will target? Like, does HelioCloud's putting stuff in S3 to make it available? I should probably know this. What other things are starting to show up there? That's kind of my question.
Winley, you want to take that one?
I'm not aware of any other S3 big S3 catalogs. I mean, SDO ML is on there.
Yeah.
But yeah, the nice thing is we don't have to. You can just specify which S3 bucket that you want to link to, and if it's accessible by you, then you should be able to read it from using the PyHC packages.
Yeah, it's kind of a chicken and egg problem. People don't want to put their data there yet because then how do people get to it, right? And so we got to solve this one first, and then people are like, oh, well, now it's there. Now we can develop these cloud apps. So, but yeah, isn't CGS, they're putting some stuff up there, and there's all kinds of
some stuff, but it's not an actual catalog.
Okay.
John, was that your question that you had put in the chat as well?
Yes. Yeah, that was it.
Okay. I was just trying to go through the order in the chat. So Jonathan Niehoff, I believe you sent some links about SpacePy.
Yeah, just showing people the discussion of our motion towards supporting non-file containers of things. Okay. You've seen it before.
Yeah. And then
Are Paul Wright and Sandy's comments towards Brent? I wasn't sure for which part of the conversation, sorry.
Sorry, I was just saying that there was a NASA on the opendata.aws, there's like a NASA Space Act thing where you can find all like NASA data sets. Maybe not for Helio, but for other things. I know the SDOML's there. But...
Yeah, I don't know if there is an actual master list of like all the data resources that's out there. There could be different lists that are managed by different groups. And so I know we're aware of the ones in HelioCloud, but beyond that, we would just have to probably look dig some.
Yeah, and Sandy's comments worthwhile mentioning that there's the Helio Cloud project is defining a way to create a listable catalog API on S3. So if you're trying to figure out how to do that, there's one suggestion.
When we address Jim's question. Darren, I don't know with your question about S3 growth in space pi, to include PyBats.
So Darren, there's really two things on that. One is, yeah, that is going to include the ability to grab stuff in PyBats, but it's going to be very naive. The bigger thing is going to be getting SWMF output into HDF5 and specifically cloud optimized HDF5. And that's a big effort that is definitely dependent on Dan. I'm not able to do the lift on that.
All right, good to know.
Then looks like there's just other comments out there.
Okay, it looks like we're just getting, like you said, a lot of comments at this point. Thanks, Brent.
Thank you.
Yes, and thank you again. Alexander, you prefer going by Sasha, right?
Yes, that's correct.
Okay, sorry for messing that up earlier.
No, it's all right. No worries.
So again, thanks to Sasha and Brent, where their talks, a lot of cool stuff going on. Now we will pivot for Sean, talk about science platforms coordination.
Yes, we will. So I will, all right. Are we sharing just Google Slides here?
Yep.
Sweet. All right. Well, without further ado, I've got 30 minutes to talk about this, and I don't know that I'll need all the 30 minutes, so might reclaim a little bit of scheduled time here after we finish this. We'll see how that goes. But yeah, I'm here talking to you today about a new idea working group that was formed pretty recently. Sort of something stemming from the work with the PyHC environment that I'll also be covering a little bit in this talk. We're calling ourselves the Science Platforms Coordination Working Group. So basically, I'll just quickly go over what this working group is, why it was formed, how it relates to the PyHC environment, and then I'll give you an update on that and everything that we plan on doing here in the near future. So basically, in just a few sentences, the Science Platforms Coordination Working Group is something that's going to be aiming to create shared heliophysics software environments. So just a way for people to have, say, Dockerized Python environments, or even better than that, to go do their work. This was sort of inspired after I presented my work trying to create an environment with the PyHC packages at IDEA last year. So if you were there, you would have seen that talk. And shortly afterwards, just a few of us in the community kind of met together to discuss what I had accomplished with the PyHC environment and what was good about that. And we pretty quickly started deciding that this would be helpful for just, the community at large, not just something that PyHC could benefit from. So on December 4th, we officially decided to make ourselves a working group underneath the IDEA umbrella, and we've been meeting monthly ever since. And so when we say creating shared software environments for heliophysics, at the moment, we're just talking about Dockerized Python environments because that's the easy thing to do. But we hope to make this browser-based sooner than later. One person during one of our meetings showed off a neat little web-based tool where you can basically imagine a web page with a drop-down menu of some Docker images, and you could select which one to use and fire up, say, like a Jupyter Lab session using one of them. So something like that would be pretty slick. And sort of one of our first output goals is to publish a paper on any kind of environments that we create and get DOIs for them to make them easily citable. And I'm saying environments plural because we're not going to be so naive as to think that we can make one environment that fits every single scientist's needs, right? So we're expecting a few different flavors of this thing to fit different kinds of development needs. But just having this sort of thing in general would help coordinate lots of the software things that we talk about all the time, like versioning and package dependencies, and it would improve reproducibility. You can imagine someone writes a paper doing some kind of heliophysics work, and they can just say, to run this software, I used this software environment from this working group. Here's a DOI for it. Go use this environment if you want to reproduce my work. Something like that would be really sweet. So here are a list of the members at the moment in no particular order. I just sort of copied them from the last meeting minutes. I will say that I was nominated to be the chairman of this group. And then Jan, who I believe is over at ESAC with Arnaud, is the co-chair at the moment. So we're the ones kind of running the meetings and the minutes and all that. But if you look at the member list, quite a few of them are on the call. So hi, everyone who's a part of this and on the call. So just to kind of give you all the full picture of this, I'll quickly go through some subset of the slides that I presented at IDEA for the stuff that encouraged this. And if you've seen that before, I apologize for that repetition. I'll go through it pretty quickly. But then that'll sort of lead into demoing what's current with the PyHC environment and where we're taking this working group in the future. So now these are slides that I presented back at IDEA, and where I was talking about making a unified Python environment and publishing the images in Docker Hub. And I want to do this because there's a lot of PyHC packages. For those keeping count, we've got over 80 now. And I just wanted to get a grip on what dependency conflicts existed. I've been getting a lot of reports that people were having difficulties just installing new PyHC packages into their pre-existing environments because there were dependency conflicts or whatever. Helio Cloud reported some trouble doing this. So I wrote a little script that you're seeing here on the left that basically generates a nice big spreadsheet of all the packages that PyHC packages depend on and what their allowed version ranges are. And that looks something like this giant monstrosity in front of you, where along the top are PyHC packages, and then the rows running along the left are all their dependencies. And then the second column there is an allowed version range for that package. And spoiler alert, there's no conflicts in there. That was kind of an aha moment, like, oh crap, it's not just there are dependency conflicts everywhere, but there's just a very slim range of package versions that we should be using. So basically exactly a year ago now at the 2023 spring meeting, we had a hackathon to try to build the environment that this spreadsheet was suggesting we could make with these version ranges. And that basically looked like just starting with importing a bunch of packages, and half of these failed in the beginning, but they would comment out the ones that were failing and then, see what was wrong, go back and fix the issues. Eventually, we were able to actually create that environment. It was valid and it worked. So we stuck it in a GitHub that was just underneath my own personal GitHub profile at that point. But this was like, hey, here's how to make this environment. And then I took it one step further and Dockerized the environments with a Jupyter Lab build, and I put them in Docker Hub. So 3 different versions at the moment, which are still being created today. With the PyHC environment is just the base image with that little import test you have in there. So you'll get a Jupyter Lab session with one notebook, but all the packages are pre-installed. And then PyHC Gallery and PyHC Gallery with executable paper are identical, except they also include notebooks from the PyHC Gallery or also the executable paper that a few packages wrote with me. And that was sort of just to, have something in the images out of the box where you could just click a play button and watch the PyHC packages run the code, kind of prove that everything was working. And I'll skip through these slides. I think the point was just to show that I gave good documentation on the Jupyter, the Docker Hub pages, so you would know what you're looking at, and it links back to the GitHub repo, etc. And here's what it would look like when you fired this thing up. But you've seen Jupyter Lab before, so that's probably not too surprising. Now, the future work at the time was I wanted to do some further testing of this environment. And I thought it'd be great to have some kind of CI/CD setup that would automatically republish this environment when PyHC packages released updates. And ideally, I would like to get emails and such if a package made a release that actually did introduce a dependency conflict for the first time that could not be resolved. I would sort of break the build, and I would like to get an email and that sort of thing happens, which could just trigger community discussions about what do we want to do. And at some point, we've been floating around the idea of requiring compatibility with this environment at some level, maybe when we start to have different evolving package tiers or something like that. But yeah, that's pretty much the end of what I had talked about at IDEA. So that was back in October, and there have been updates since then. So this is the part where I tell you what those updates were. So since October, I have done some further testing of the PyHC environment. It's annoying at the moment to run unit tests in the thing because you have to actually have you have to clone the repos of the packages. You don't just get the unit tests when you pip install them, right? So just on my own, I've kind of dragged in a folder of the repo and run PyTest or whatever for at least the core packages and proved that they've worked. So there's still more that could be done on testing this environment, but I'm giving it a green check mark. And then I actually did build some CI/CD with GitHub Actions, and I will demo what that looks like here in just a minute. And I would just say so far that's been working. Nightly, we've been checking for new package versions. I think maybe 5 or 6 times since I made the GitHub Actions workflow. It actually has successfully updated the Docker images in Docker Hub, which is pretty cool. No community discussions have had to happen yet because no dependency conflicts have been introduced, but I'm prepared for them if they happen. And we're still not requiring any kind of compatibility, just to be clear with that. We have not gone there yet. But this is the new GitHub repo that this is in. It's now underneath our Heliophysics Pi GitHub organization. And I think I'll actually skip past these slides and just go straight to the demo. We've got a few things in the chat, but I think like the other talks, I'm gonna mosey on through and I'll get to questions and comments at the end of it. So let's see. Yeah, right about here. So I'll just pop over. Hopefully that changed the tab for everyone and we can see inside GitHub now. So as it says over here in the about, this is a pipeline to generate and Dockerize Python environments containing all published PyHC packages. So just to give you the lay of the land real quick, the main script in here is this pipeline.py file, which I won't really run through the code, but basically the steps are to generate that spreadsheet that I showed at the beginning and then see if there is actually a dependency conflict or not. And if there isn't, we update requirements files, and then in GitHub Actions, we build and push Docker images and push them or whatever. But this is the part that actually checks if the pipeline should run. And basically, it's just comparing the versions we have in our requirements text files to what's in PyPI. And if it notices a version in PyPI that's newer than what we have in the requirements files, it decides it should run. Otherwise, nothing runs. And like I said, the first step is to generate these little spreadsheets. So I've got a spreadsheets folder in here, and I can't actually open Excel spreadsheets in GitHub, but they're there. And I have a lovely little README here that explains what you have, and it's got links to the Docker images in Docker Hub, and I've got a little table right here that's showing what versions of the PyHC packages we are using at the moment. And this is what all gets updated automatically. So actually, because of the SpacePy update, this just got triggered last night. So you can kind of see it automatically updated SpacePy to the new version, and it updated that in 3 different requirements files for the Docker images, and we got a new spreadsheet. So let's see. I'll try to go through the rest of it a little bit quicker, but here, if I can click the Actions tab for those who are interested. There we go. So basically the way I have this set up, and I can dive deeper into this if people would like to see how I actually managed to pull this off. Up until here, we're just like getting Python 3.9 ready and getting the repo cloned. Running the pipeline script, here's where it noticed updates are required for the following packages, SpacePy. So it updates the version in the README table, and then it tries to build and push the Docker images. And if that succeeds, then it takes the changes to the new versions that were created in the repo and commits it back so that the repo always stays in sync with what is in Docker Hub. But if any steps right here fail, the steps below them will not continue. So if, say, for some reason, it failed to push an image to Docker Hub, or it failed while building the image, I would not commit those new versions back to the GitHub repo. So nothing would get out of sync. It would basically just try again the next night. This is running nightly at midnight, by the way, if I didn't say this. And then I've got a neat little hack over here, notify on successful push, which this is just, I don't know if there was a nice way to do this, but I thought this was neat. How every time there's a successful Docker push, I can have this little bot make a comment in this issue, just saying the Docker Hub images and GitHub repo have been updated by GitHub Actions. And then I get an email every time that happens. So I get emails anytime this fails, which would indicate that some kind of dependency conflict was introduced to the environment, or I get emails when a new version gets published, which is all really nice. And I guess one thing I didn't really touch on, so this is the last thing that I'll show, is when I'm making these Docker images, really I'm just updating the requirements files and then rebuilding the same Docker commands. Unfortunately, it's not quite as straightforward as just doing one pip install -r to a requirements file. Our packages are a little bit finickier than that. SpacePy is getting called out here first because it used to be I would need to have NumPy installed and then run it with this no build isolation flag. But I suspect that is no longer the case. So John, I will soon be removing this custom little bit and seeing if everything.
Yep, it shouldn't be. I'm tempted to go open a pull request while you talk.
Yeah, right. But so that'll be handled. And then like with PySpeedas, you need PyTplot MPL temp installed before you install that, or the PyTplot versions can get confused. But I'm keeping track of these issues over here in issues. So I've got a pip install complexities that mention what I'm doing there, and any version compatibility things that stop us from using the latest version, I'm also keeping track of, which at the moment, CDFlib is the only one. And if this is a big deal for anyone, I do apologize. But yes, CDFlib back in, I want to say June of 2023, made a major release to 1.0 that many packages, including PySpeedas, haven't gone toward yet. So we're pinning this to 0.49 at the moment. But yeah, that's what I've got going over here in GitHub. And just to show you for 1 second, I mean, this is the Jupyter Lab interface you get when you fire up any of these Docker images. And I've got this import test in here, which the first time you run it will take upwards of 5-ish minutes, and because it does a lot of things. Packages like to do stuff when they're first being imported for the first time, but it just passes afterwards. All the PyHC imports worked. Woohoo. And just to show it doing like one other thing, I can like use SpacePy to get planet positions, and woohoo, I'll click run, and my computer will be slow because Zoom screen sharing is taking compute resources, but it will output a figure because the environment is valid. And that's probably all I can say for that. If you want to check these out, I'll put a link to this actually in the chat right now, and then I'll start to look at what's in the chat. But also remember, go here to the README, and you can get a link to the images in Docker Hub. And you can click tags here, and it gives you like a Docker pull command to pull this into your environment. Yep. And
there's a lot of various things in the chat. I can pull out what the actual questions are. I've been trying to shove in notes while this is happening. Can you get Sasha?
For the sake of time, we should do that. I'll answer some questions, and I'll end with closing thoughts on where the working group is going in the future. But this is a good enough time. Yeah, so questions.
I'll have Sasha, you go first.
Oh, thank you. Yeah, so as you know, we start doing this installing all these packages on Windows, and I know there is some issues with running Docker under Windows. Do you think it's still worth pursuing just to have like the way I was doing is creating the sandbox and trying to install as many packages as I can? And I wrote a bunch of scripts supporting that install like correct libraries, environments. So is it still worth pursuing this direction for people who don't want to deal with Docker?
I mean, I would say it's still a valid thing to pursue, and I agree that not everyone's going to want to use Docker. So eventually, like I said, we would kind of like to be able to have this browser based so that you can just go to a URL and just be working with Jupyter Lab right there in your browser. But there's infrastructure requirements that make that not quite yet possible. So I don't know that I have a great answer to that other than like it might help someone. Yeah.
All right. Thanks.
Okay. Brent had a question a while back. Sean, what are you using for your base Docker image? Also, are you going to impose a Docker image file size so that it's minimized for use with those interactive documents?
Yes. So I am using, I can actually just pull it up right here in 2 seconds. I'm using the Miniconda 3 base image. And this is the compressed size right there is 1.33 gigabytes for the PyHC environment. I've been trying to keep it not egregious. I've been told that's somewhat reasonable, but I am putting more of the focus on actually making sure all the packages are included rather than shrinking the size of the thing. Yeah. And then Nick gave a link to my GitHub repo before I had a chance to. Thank you for doing that, Nick.
You sure did.
Yeah.
Let's
and
see.
Rebecca got the link to the idea.net where you can see the working groups. I know someone asked about that.
Yeah, Nick had also, Sean, have you thought about adding the test from the package repo? Sorry, this is actually not Nick. That would be a much bigger task. It could be something to suggest for each CI, maybe on a weekly basis.
I've definitely thought about that. It's technically not a hard thing to do. It's just kind of a lot of busy work. And I was really hoping that we would be hiring a student intern for PyHC this year. And that was one of the first tasks I was planning on giving them was unit testing the PyHC environment. But other things like this Heliophysics software search interface that we're going to be talking about pretty soon, I think are starting to take priority over that. And I didn't say it before, but because I'm seeing weekly is probably a more reasonable rate, that yes, once we eventually create an environment through this idea working group, the idea is for it to not be updating nightly, but for it to be more stable and maybe only update like a few times a year or something like that.
Indeed. Sorry, one second. I know Nick had a comment at some point. I'm trying to find it. Oh, would it make sense to add a CI run to test building the environment from GitHub repositories of each package, or perhaps just the core packages? That way we would be able to find out dependency conflicts before releases.
That's definitely one way to do that. One thing we would like to have eventually is actually to have packages be doing release candidates before they actually push out releases to PyPI. And then one of the requirements for accepting the release candidate would be proving that it is still compatible with the PyHC environment. So I think that's more like the permanent solution, but we have not gone there yet.
Right. And then the other thing I'm seeing was from Rebecca. There's an effort to understand what packages the community uses even outside of PyHC. At Sean, should I put the survey form link here?
Oh, yes. You should put that link here, Rebecca, and I should actually finish the last slide of my talk.
Yes, you could continue. I think I captured most of what was actual questions.
Yeah, I think you did too. Really just like one more slide left here. Because the last time this working group met, I was basically giving them that demo of the new GitHub repo for publishing the PyHC environment. And people were generally agreeing that that was a pretty good setup, or at least a workable one for now. So the idea would be to sort of now contact members of the Heliophysics community and ask what their needs are for a software environment, and then go try to create one. Rebecca led the creation of a Google Form survey, which I can just flash here on the screen, although I'm not going to go over every question, but it asks simple things like, what categories of science do you do? What software do you use when you're doing this kind of thing? What version of Python? And at the end, it asks like pip freeze output. So we can get that kind of thing to get inputs. And then next Thursday, actually, immediately after this spring meeting at 11 a.m. Mountain Time is when we're meeting next. So this is your reminder for those of you who are a part of this working group and on the call. You still need to be on Zoom immediately after the PyHC spring meeting ends, because we're talking. We're basically just going to be reviewing those survey responses or any that we got and just kind of going from there.
Thanks.
Yeah. Yeah, that's, I think, pretty much it. I'll leave these links on the screen for just a second in case you want to check out the Docker Hub or the GitHub repo. And yeah, I encourage people to actually check this out. As so far at the moment, this has sort of just been like something I've been doing on the side. I don't think anyone's actually using the PyHC environment yet for any serious research. But if your package is in the environment, maybe go check it out and run some code and make sure it works as it should. And let me know if it doesn't. Okay, I'm going to stop there.
Thanks, Sean. I don't think I see any new questions littered throughout the chat. Does anyone have a question off the cuff they just want to ask out loud? Going once, twice.
I'll
John.
ask mine when we talk later about software stuff. But one thing I'll just put it out there for now. It would be really interesting for reproducibility to have a kind of almost like a data environment that people could publish their data in a certain way, arrange it this way on Zenodo. And then we developed, of course, it's about happy, right? So we develop a happy mechanism that could read that structure and that data, and it would sort of permanently be accessible via happy. And it might be that there's a container that had the mechanism that could read that data, but it would also almost be like a data container. So it doesn't quite fit with this discussion, but it just something as we talk about cataloging stuff or, open science, that could be something PyHC could contribute towards.
Yeah.
And then, you publish your data, it's in Zenodo forever, and it's in a layout and a structure that a happy server could sort of permanently serve it from there. That would be super cool.
And it'd be citable and all of that.
Yeah. Anyway.
Cool idea.
Yeah.
It's written down, so the thought's been captured somewhere.
Yeah, we've talked about it with happy meetings, but we only have so much bandwidth there. If anybody wants to propose that, that's probably a great fundable activity.
Yep.
All right. Well, if there are any more thoughts or questions or comments or what have you, direct them towards the chat. We're going to go ahead and move on. But thank you, Sean, for updating on us on that. And yeah, the excellent demo. That survey link that Rebecca referred to in the comments is posted in the comments now. I also captured it in the general meeting notes. So please go and take a look at that. All right. Without further ado, we have Eric Lopez here from EMAC. He's going to give an overview of that platform and tell us a bit about how they do their searching for exoplanet data and so forth, and then some of the metadata structure behind that, with the end goal of us having something similar for heliophysics software. So that's a recent ongoing effort. Full disclosure that we're trying to put some kind of proposal on. So more to come on that, hopefully in the form of funding soon. But either way, this is a direction we've been wanting to go for a bit, and we're finally trying to make some steps that way. So take it away, Eric.
All right. Let me see if I can actually successfully share my screen for once. Can people see me?
Yes.
Sure can.
Okay. Now can I remember how to actually play the dang thing? Well, I'm not going to bother since I'm going to
should be the slideshow tab along the top in between animations and
there we go. I normally use Keynote, but our slide deck is in there we go. Well, hi everyone. So I'm Eric Lopez. I'm a exoplanet scientist at NASA Goddard. But as Julie said, we've been talking a bit because we're also in the business of trying to host and provide web access to a repository of models. And so very similar activity to what you all are doing. And so thought I'd come I'm going to spend most of the time just actually showing you our actual website and some of the things that we do to help people host, find, sort, compare different models, how we load those, how we recruit them, how we get people to submit them, all of that, and then hopefully we can inspire each other and share some horror stories and lessons learned and all of that good fun. So just quickly to give you an idea, we're a pretty small team. So myself and Joe Renault, who is a postdoc here at Goddard, are the co-leads for EMAC. We have one other civil servant, Avi Mandel, who helped start EMAC along with myself back in 2017, I believe. We have currently one post-baccalaureate researcher, who Ashraf Dawi, who is the one who actually makes everything work. We've been very lucky with a long string of post-bacs, either from astronomy or very often computer science programs, who've been invaluable. And then we have our two devs. We have a front-end web developer who's an engineer here at Goddard, and we have a back-end developer who is the one that actually knows how Django and Docker work and actually gets everything to compile. So just quickly, what is EMAC? What are we doing? So we are the Exoplanet Modeling and Analysis Center. And so quite similar sort of idea. Our remit is all things exoplanet modeling and analysis tools. So we try to be a comprehensive searchable repository for exoplanet science codes and also analysis tools. And this can be, all sorts of things. It can be web apps, it can be observatory simulators, it can be just grids of pre-computed models people have. And we have sort of different tools for trying to help people find and use all of those. And then just give you an idea, I should mention, we're funded directly from headquarters as part of this internal Goddard funding model, this called SEEK, the Cellular Exoplanet Environments Collaboration, and funded partly from both the planetary science and the astrophysics division. So give you an idea of, what have we actually done? We've go out, people come and they submit their codes and their tools to us. We also go out and actively recruit them. We see a new code is published on the on ADS, and we actually have a whole automated email system to send them saying, here, you should go submit our tool. And this is a little bit out of date. I believe we're now up to 250 tools in total. Most of those are Python codes, I should say, probably 80% of those. But then there are also codes in other languages. There are web applications. There are libraries of models and other things. And then last year, we had our first virtual workshop for all of our devs to present their tools, to have, open discussion about coding practices and various panels. And I believe we actually ended up with almost 400 registrants attending, and went very well. Now for the meat of it, I'm going to try and do the fun thing and actually share my browser and actually step you through the website. So, okay, hopefully everyone should now be able to see our nice, shiny, lovely website.
Yes, we can.
So this is EMAC. You go to emac.gscc.nasa.gov, and this is what you get. And so the first main thing are these tiles for the different resources that are loaded. And so obviously 250 is a lot of resources. And if you just scroll, we're actually now, in this nice situation where you can be, infinity scrolling. So we've created various ways for people to try and find the resource for the specific question they're trying to ask. So as Julie kind of alluded to help with this, we've collected lots of metadata about each of these resources. So for example, we have just a simple search feature. So I can search for models that have to do with tidal physics. Okay, that pulls up 9 resources. For each of these, it will be categorized by different science categories. So for example, planetary dynamics, planetary interiors, planetary atmospheres. I can also click on that, and it will filter down to just the atmosphere ones. I can clear all of that, and let's say I want to just pull up all of the atmosphere models. So we have this over here. I can pull up all of the atmosphere models. Maybe I don't want all of the atmospheres. I just want 2D and 3D atmosphere models. Okay, we don't have that many of those. Let's do 2D, 3D, and what? Let's do chemistry models. What do we? Oh, we don't have any chemistry. That's surprising. Retrieval. Oh, sorry. Got to clear. That's why we have the reset button. It's filtering down. There we go. Takes a little second to load, but now let's pull up our 1D atmosphere models. And okay, we have 23 of them. And so then for each of these, you can see we have a description. These are generally provided by the actual model developer. We have the various science categories. We have a discuss board. These are generally, the way we do this is actually it's a GitHub discussion page. Whenever possible, we encourage all our developers to upload their codes to GitHub, and then our link is actually links to that. Sorry, let me hide the participant view so I can actually see what I'm doing. So this code button, this is a link to the GitHub page to actually download the code. For each of them, we have this citation ID, sort of similar to what you were talking about. This provides a unique link to just the tile for this tool that is, so it's a permanent stable link that you can also then export a citation to cite that particular version of the tool. You can copy that link. We have a feedback page for ones that are have a publication associated. We link to that on ADS and list the number of citations. For some of them, we have video tutorials. These are demos, which are usually short. We have a YouTube page where we uploaded those. And those are, some of those we film ourselves. Some of those are provided to us by the developers. We also link to, we cross-list things with the astrophysics source code library. And so we, when those are available there, we list that as well. You can see we have a lot going on in these tiles. Yes, some of these will have web applications. Generally, these are APIs developed by the model developers. In a couple cases, they are ones where our team actually developed them, where we decided it was really useful for us to do that. And in some cases, we also have Jupyter Notebook tutorials that have been developed by the devs, in addition to, okay, you can go watch their YouTube tutorial, and then you can, while you're watching that, along with that, you can interact with a Jupyter Notebook. So that's kind of the first level. That's the home page. We also have other ways of categorizing the resources. We categorize them by type of resource. So is this a code, a downloadable code? Is this a catalog of just data that's downloadable? Is it only a web interface? And then something new we've launched recently is custom collections related to different science cases or observatories. So that's kind of the home page. And then the way we actually get this metadata, all this information about, generally what we do is we encourage the devs to submit all of this information on our page. So we see somebody, we automatically scrape every week. We have a automated code, searches all the new papers on ADS, and looks for keywords associated with exoplanet modeling, flags it to us. If we decide it's relevant, we click a button on our admin page and it tells them, hey, you should go submit. And so then people go on here, they submit all the relevant information, their name, their email, all the descriptions, and all of the various links and images and everything else that gets loaded there. And in practice, we end up, some of this we have to collect ourselves or end up chasing down. But we found that something that's very helpful is automating as much of this process as possible for us, just to lower that burden, while at the same time making sure everything, before anything actually gets pushed to the public site, there is a human being looking at it and making sure people aren't trying to post NFT nonsense to a NASA site, because people do try and do that. We also have a page for people to subscribe for updates about tools or categories of tools that they're interested in. And so we'll send out a monthly notification about the categories that they're interested in. We have various things: FAQ, team page, news. We have a seminar series that we co-run with the Astrophysics source code library. We developed a page just that came out of our workshop of some documents of best coding practices and hosting practices, and some of our lessons learned, and some resources that are just kind of generally useful on our page. And then our new thing, this login page, this is for, we're recruiting what we're calling curators, which are people outside, mostly volunteers outside of our team, who are volunteering to help a little bit with recruiting tools, seeing is there anything there out in the literature we've missed, and with helping build up those custom collections and things. And then just to give you an idea, we also, this is one of our amazing postbacks made, a page that actually links to Google Analytics and automatically downloads and plots various analytics about visitors, number of sessions, number of new unique visitors, and all sorts of what tools they're going to, and all sorts of other useful information. This technically isn't actually meant to be seen by the public, but we have it not that well hidden. And then the behind the scenes, we try and make sure our general philosophy is that our users are, generally speaking, we want it to be as low an entry bar as possible, because plenty of scientists like myself are terrible coders. I'm an old dinosaur who codes in IDL and is basically useless. So we try and make everything as much based on the web front end and as easy as possible, while at the same time we have a back end that's quite sophisticated, that is running Docker containers with a back end interface managed by Django. And so the way we actually interact with that back end day to day is we also have this admin page, which just our team uses, this is how we actually push and manage that information. So we have a new resource and we want to change some of that information. We have this back end database, which I will try not to fiddle around with too much before I accidentally delete something. But I think that's it. I wanted to give people just kind of a general overview of what we've done. But leave a lot of, I have plenty of time to talk with people, and I'm sure I'm happy to share horror stories and things we've tried that did work and didn't work and so forth. But I think I will go ahead and stop there.
Thank you, Eric. It looks like we have a couple questions in the chat. Sean had wondered where the add a resource form was. I went ahead and sent him that link on your behalf. But Will Barnes asked, does EMAC have any overlap with ASCL, which I think you had some boxes showing.
We do. So that we've been started talking with them quite a bit in the last year. Their remit is overlapping but different. Their goal is simply to find all open source codes that are out there, all open source astrophysics codes, and basically just provide a simple listing. We're not just limited to codes. Mostly it tends to be codes. I think, and partially because though it's young early career people with open source codes are the ones who tend to be motivated and actually submit resources. But we also host web apps, we host observatory exposure time calculators. Something we're trying to make more of an effort to host now are these databases of pre-computed models, where people, their code might not be very usable, but they have pre-computed grids of models that might have taken them thousands of hours, and people might be able to get quite a bit of utility out of, and we can also help provide a citable location for those. but yeah, where possible, we if it's something that's also on ASCL, we try and list that here, and they are now starting to list EMAC things on their site.
Awesome. Rebecca also had some questions. What's the reasoning to include stellar catalogs in a software search interface rather than on a data search interface? Would you change that if you could start over?
So our philosophy, it's an interesting question to start out. I think I would stick with things. Our philosophy, first and foremost, was to sort things by science and by broad science categories and broad classes of tools that might be relevant to exoplanets. And so in practice for exoplanets, what stellar models tends and catalogs tend to mean, it means catalogs of properties of host stars known to have planets. And okay, I want to model I have a transit from TESS of this planet, and I've reduced that data, but I know nothing about the star. And you only know the planet as well as you know its host star. So I want an easy spot to find a catalog of what are the known stellar properties of this group of M dwarfs. And so our goal was kind of to try and be a comprehensive repository where people could find, especially like say a student starting a project, they could find all of the different code packages that they might need to interact with each other, and all of the different properties of a planet's equation of state and the spectra of its host star that they might need for the project, that they could find them in one space. So yeah, in practice, is mostly is just catalogs of input stars to transit surveys, and then some reduction pipelines for reducing spectra of host stars, again, to get stellar properties for informing planet properties.
If I can comment?
Yeah, go ahead.
So let me say my background. Maybe that came out in earlier meetings, but I'm from data infrastructure and heliophysics at NASA. And here my concern is there's starting to be some sort of overlap in responsibility between data archival and software archival. I think your website's more focused on software search, but you also provide a persistent identifier too for software. So here I start worrying, and I see it in other places in infrastructure too, where there becomes this confusion between responsibility, because data archival is a very different process from software archival. They must be linked to be useful to each other. But I worry about that overlap in responsibilities because a group that understands software archival and a group that understands data archival, they have complementary skills, but it's very different. And we don't want one group to have to learn the skills that the other group would rather distribute based on strengths. I'm interested to hear your comments on that.
No, I think that is a good point. It's certainly like the group I interact with quite a bit is the NASA Exoplanet Archive that's run by Jesse Christensen and the group out of JPL. And yeah, certainly we definitely do not want to reinvent that wheel. That is a whole different process, and trying to be a comprehensive data archive would be well beyond our scope, and that's a whole different set of expertise that needed. Our general goal here, we're not storing everything. Some things, people send us a grid of, here's this code, and I, pre-computed a grid of 10,000 runs of this 3D atmosphere model. And okay, we're happy to host that. That's a model product. So we're going to store data from model products and things, but we don't want to. We are not the place to store the catalog of host stars, for example. We don't host star catalog. That is not data that is stored here. Generally speaking, that's data where we're linking to a site. This is a good example here. So we're linking to a data file at the Exoplanet archive, which I think I just downloaded. We'll link to Gaia data. So stuff like that, we're not trying to take on storing or figuring out how to organize that data. Our just general goal is, if somebody is on our site and they know the sort of data they need to find, but they don't know where to look, then we can point them for where to look. Somebody knows, okay, I need to find information about these stars, and they just, search for host star properties, that they should then be able to find something on our site that links them to a database somewhere else.
Yeah. I have some ideas on this. I don't know if it's in scope for this discussion. Julie, defer to you.
There we go. Found the mute button. If you can give them briefly.
Okay. So Eric, maybe let me just do this. Eric, I think we should chat separate from this. I don't want to detract from the conversation, but there's some ideas we're working on in Heliophysics to link software and data more tightly, but without listing them both in the same search results. Maybe you would be interested in that.
Certainly. Yeah, I'd be happy to chat some more about that. And one thing I should say that's quite helpful and a little bit unique in our case is because we are at a NASA center, we've been able to get resources on a NASA cluster. It's called the Discovery Cluster. It's kind of a medium-sized high-performance computing cluster here, which is that our actual, Docker and Django environments, and our data storage is all done on that. It's not, we're not using a huge amount of space and resources there, but from the point of view of a high performance computing center with, I don't know, I think it's like 100,000 GPUs or something, but by being able to have access to that basically for free has certainly been very helpful. And if we didn't have that, there probably would be we probably would have made some different decisions about what we were actually hosting and running locally on our site versus just pointing to other people hosting or asking people to run locally on their machines.
Yeah, let's chat more. Wow, let's chat more. I'm emailing you.
Well, are there any other questions directly about EMAC or about, Eric's presentation in general?
Yeah, this is great. Yeah, this looks really neat. The community's really come together for this. The thing we're discussing next is, metadata for software cataloging. And so, do you have a schema for your metadata or something? Or, you take new submissions, right?
Yeah.
And so how do you regulate, or how did you decide? Some of this is very domain specific, like you couldn't just drop all these categories onto other fields. But,
So
what lessons do you have about the metadata?
One of the big things is try and start from the beginning, building a infrastructure that's as flexible as possible, so that you can add things as you go along. I should say looks almost nothing like the site looked 4 years ago. 4 years ago, okay, we had a description, we had a title. I think, yeah, we had a developer and that was it. And every, couple months, we come up with a new idea. Oh, it would be cool. Okay, we have this. And then we go to our web designer. He kind of rolls his eyes at us and, okay, how am I supposed to squeeze another piece of information onto these tiles? But then he makes it work because he's fantastic. But yeah, something that was very important was before we launched anything, before the website went live, we had our original back-end engineer who was he's since retired, but a very experienced, fantastic engineer with, tons of experience in web systems management and server management. And he built our whole back-end infrastructure that runs in Django and Docker. He built that all up, made sure everything worked in our servers, and that we could parse all of that information. I should say, in addition to this, something that's very helpful is make sure you have a dev environment. It's talk to professional programmers and follow their practices. So anything before anything ever gets pushed to our live production page that we show here, we have a dev environment where we test everything out. We test it internally, and very often it does break things. And we make sure all of that is managed on our own GitHub, and we make sure we're very careful about version management and pushing everything. And all of those just programming best practices. As soon as you have a team of more than 2 or 3 people that are working on this, becomes very important. And then for the actual getting the metadata, first and foremost, try and get that from the people that are actually developing the code, because they will know best. But in practice, try and have a infrastructure to make it as easy as possible on yourself to add and modify those things. As a lot of these things, we've added over time. Things like the code language, we added that quite recently. So actually, generally speaking, that's something we all added. And we went back and looked at our tools and spent a day looking up what version of Python were they all in, or were they in Fortran, and then uploading that. And then we go to our admin page, which makes this really nice and manageable. And okay, I can go click a resource and I can go look it up. And for any given resource, we have these various actions that just quickly make it possible to change anything. So I can publish a resource to the site, I can unpublish it and retract it very quickly, I can add it to a collection, I can change its resource type, all of those various things just at a click of a button without actually having to run any code. Which also, the nice thing, even for our admin actions, we generally try and make it so they can all be done via a web interface rather than by actually having to go to the command line, which has also been very helpful since a lot of our day-to-day work is actually, a lot of that's taken up by our postback. So we have these fantastic post-baccalaureate researchers who come in and spend a year or 2 working with us. And having something that's relatively quick and user-friendly, it really helps with, they can usually get up to speed in a month or 2, and they're doing a lot of the day-to-day admin. So I should say it's also very useful. We have a giant Google Doc with we built up, we call it our knowledge base of how everything we need to do of how do you log into the Google Analytics page, and how do you download that, and How do you, synchronize things? How do you push to dev? Where's the GitHub page? All of that, just keeping track of all of that becomes very important when you start getting regular turnover in your team. And then I guess the other thing that also just a practical thing that I found quite useful is we have a Slack for just our core dev team. And we do pay for that Slack so that we can search through the whole history and we can remember, wait, we have an idea and then we can remember, wait, I think we talked about that idea a year and a half ago and it was tricky and we stopped working on it. Why did we stop working on that? Nobody can remember. Going back and finding that again can be quite helpful.
Awesome. Rebecca had one more quick question. Are the metadata records based on data site in the background to some extent?
I'm not quite sure I understand the question.
Rebecca, speak up.
Will do. Okay, so data site is generally the metadata registration is how you get a DOI. It's what Zenodo uses for software. Do your records connect with the data site metadata record for a particular software, or do you all create a record for that?
Not exactly. So we don't currently generate a DOI. We've thought about that. Our current permanent link for the tile is just that. Why is it? It's being slow. So we have this EMAC ID, which is kind of our record keeper. Generally speaking, for anything that is published, what we try and do is we make sure to link to the ADS record of that publication, and so then people can access the DOI there. With associated with that, I think what your question is getting at, there's metadata that we have uniquely collected for the site. Things like these descriptions, those are things that were the developer typed out and entered in our submit a resource page. And there are also things like when it was last updated on our site, the YouTube tutorials and things like that. We don't currently have a DOI or a data record associated with that metadata. That is, I guess our thought is, first and foremost, we try and focus on things that are associated with a publication, and that that publication is the citation source of record that people should go to first and foremost. And metadata that we have on here, in addition to that, are things that we're just trying to collect for a particular purpose on our site for ease of the user in finding things. Like maybe they only know Python, so they only want to find things that are written in Python. So that's a useful thing for them to know. I don't know if I answered your question, but
yeah, you did. It would be interesting for the metadata research groups to have an API to access the metadata so they could study connections and those kinds of things.
That is, connections. One thing I forgot to mention that we do have, it's not a huge number of resources, unfortunately, but we do actually have this thing that we call related resources, where when there are resources that have a known connection to another code on our site, it's an offshoot or it's developed using a connected code base or something, we link those together with pairs of resources. That's something we want to expand in the future. We've talked a lot in the past about trying to figure out ways to link tools together, and could you take the data outputs of one tool and run them as the inputs into another tool, and wouldn't that be fantastic? And you could run a whole exoplanet simulation from one end to another, just all on the side, all only in APIs, and wouldn't that be great? And very quickly, you run into the problem of every single code on imaginable has different outputs with different formats. They're all their own special little bespoke toys, and none of them actually play nicely with each other. I think this might be less of an issue in other fields where there's I think a longer track record of people working on common known problems and developing coding standards and standardized data outputs. In exoplanets, that is very much not the case. And so that's a problem we have run into many times.
Cool. Are there any other questions or thoughts that came as a result of this talk, this discussion? I see in the chat, Nabil suggested if you could move any useful information out of Slack and into a wiki, that should help new people that join.
Yeah, in practice, it's not a formal wiki, really. It's a Google Doc, but in practice, it's a fancy Google Doc that's on its way to halfway to being a wiki, which we do to try and maintain, sort of permanent things we want to know. But at the same time, also just, the discussions in brainstorming, minutes of old meetings. Once you start working with a team developing these sort of things over the course of years, it becomes very helpful to be able to keep track of those old discussions, because a lot of the problems will come up again and again. Things with like security certificates, or some server goes down and needs to get restarted, that or something. Maybe this is similar to a problem you ran in the past, but a little bit different. And having the wiki is very helpful, but also having the discussion that led to that solution on the wiki, and being able to remember that whole thought process is also very, very helpful. I say that, like, as an example, with this past weekend, we realized our Google Analytics stopped updating a couple of months ago, and going back and tracking back, okay, when did that happen, and why did that happen, and how did we set it up in the first place, and why did we set it up the way we did? I was looking back through all of that discussion from like 4 years ago, and it was very helpful to still have that.
Indeed. All right. Well, we are about 4 minutes from the top of the hour. Thank you again, Eric, for coming on and talking to us about the effort. I kind of revealed my hand a little bit right before we had Eric present, but the idea is to try and apply what's going on here for ourselves within Heliophysics for a software search interface. So the question I was going to pose, although there's not really time to answer it, but really get into it now, which is fine. We can take a telecon or multiple to talk further about this, is that maybe people can answer your question in the notes from Rebecca. Sure, but I'd like to have an out loud conversation too. But the idea is to think about what kinds of things do you all with your packages want potential users to be able to search on. We kind of have a really small start with that with the PyHC website as is. We do have keywords that you can search your packages on, but I mean, that's but the start. We'd like to expand it and have a better interface, something like this that they're using for EMAC, which also HSO Connect leveraged, if I'm remembering right, and has a similar interface for their work.
Yeah, and I guess just a philosophical point that reminds me of, that something we try and go back to all the time. Like our touchstone is first and foremost, try and think about things from the point of view of our users. And you always want to, like, who is your target audience and what is their mindset and what makes things easier for them. And in our case, in practice, we have two different audiences. One is the audience of developers who are developing the codes that we would like them to share with us. But then we also have the audience of users who are trying to find codes that maybe, they're not writing anything, but they just want to find, I don't know anything about retrievals, or, here, I've got a student working on a summer project and I just want to find like what codes are out there in like 5 minutes, just what is there, and make it as easy as possible for them. And in practice, those audiences actually have very different desires and very different needs, and figuring out how to cater to both of them takes a lot of thought. And different parts of our site and different parts of our process are built around catering to each of those. So I guess it's just, the general touchstone is always try and think about your audience and what makes life easiest on them. And unfortunately, very often that will not be what makes life easiest on you, the person that's building the site.
Indeed. And John, yes, heard in the comments, write a package metadata FEP. That's certainly a good start as well. It's on the to-do list, the ever-growing to-do list. But I wanted to just get that question in y'all's minds so that, we can start thinking about this. This is going to be something that we're looking towards in the future, coming months, year or so. So
Yeah.
And yes, we're happy to share, all the actual code for building this infrastructure and our lessons learned. We're happy to help other people.
Yep. And I just shared a little link to the keywords that we use in PyHC at the moment. And actually, one thing that is really nice that you all have done over there at EMAC is you're giving people a form with checkboxes to just check if this is relevant to you or not. At the moment, we're making people write a list of strings in a YAML file to actually write out every keyword that they think is relevant to them. And already we've got a pretty good taxonomy of things, and it'd be nice to just have every package actually have every keyword associated to it that it should, and doing like a form where you can just do checkboxes is probably a lot easier than having to manually type in every keyword yourself. So yeah, maybe people can just take a look at the taxonomy and be thinking of if there's other things that we could add to that again. We've done that before, and people had more or less generally agreed that there was everything that needed to be on there, except like submissions got added pretty recently. But if you think about it from the angle of searching for your software, maybe you'll think of new keywords that should be in there.
I guess one piece of advice I'll give on that front to start thinking about now, and it's not obvious, is think about the logic of how you want your different parts of taxonomy to relate to each other. What things do you want to be, like say, you want something that's stellar models and atmosphere models, or atmosphere models and interior models. Currently, the way we do that, because we decided it made the most sense for us, it's an and logic. So we only are publishing things that are both an interior model and an atmosphere model. For some other things, you might want an or logic. And it actually took a lot of thought, and the different types of things. We have our science categories, we have our types of resources. And so things like that actually generally we use an and or logic, when it's combining a I'm talking myself in circles, but it gets very non-trivial when you start thinking about, okay, if I want something that's a 1D atmosphere model that also does radiative transfer, that has a Jupyter notebook, or maybe it has a web interface. How do I help people find those? And that actually takes a lot of thought about what is out there and how you want to present it to your users and how your users will be thinking about it. So yes, start thinking about that logic, and then you'll probably change your mind a half a dozen times.
So it goes. All right, well, we're officially over the hour, so I want to go ahead and let people go and not keep people too long. Same time, same place tomorrow. We're going to kick everything off with talking about the FEP1 that John Ehoff has been working so hard on, and it looks like he had to drop for another meeting. Totally fine. And then we're going to go into next steps and what we want to do with PyOpenSci partnership. As well as somewhere within that day include getting a link to y'all for voting on conferences. So if you have ideas for that, please be submitting to that spreadsheet. I will see y'all tomorrow.